When people ask, how much horsepower does a turbo add? They're usually hoping for a single figure, something neat and satisfying like 50 horsepower. But the truth is, there's no magic number. A turbocharger isn't a one-size-fits-all power pill. It's a dynamic, highly integrated system that works in harmony, or disharmony if done wrong, with your engine, fuel, and environment. The real gains depend on dozens of variables, and that's where things get interesting. A turbocharger takes otherwise wasted exhaust energy and uses it to spin a turbine. That turbine drives a compressor wheel, which pushes more air into your engine than it could draw naturally. This extra air, known as boost, increases the number of oxygen molecules in the combustion chamber. More oxygen means more fuel can be burned, and more fuel burned means more torque and horsepower. In short, a turbo raises air density inside your cylinders, shifting your engine's entire performance envelope upward, provided the rest of your setup can handle it. From a thermodynamic standpoint, it's all about utilizing exhaust enthalpy to increase intake manifold pressure and density ratio, while managing heat so that efficiency doesn't collapse. From a driver's standpoint, it's about pressing the gas pedal and grinning when the boost hits. A turbo's horsepower bump isn't just about slapping one on. Here's why. A 1.5-liter engine starting at 100 horsepower will see a higher percentage gain than a 5.0-liter starting at 400 horsepower. More boost means more air, but also more heat and mechanical stress. Street builds often run 5 to 8 psi. Race setups can push well past 20 psi. Forged pistons, stronger rods, and lower compression ratios allow safer high-boost operation. High-octane fuel, such as E85, resists knock, allowing for more aggressive tuning. Without proper ECU mapping, gains are capped, and reliability takes a hit. Smaller turbos spool quickly but can choke at high RPM. Larger ones flow better at the top end but have lag. A turbo offsets thin air at high elevation better than a naturally aspirated engine, but absolute gains may still be lower than at sea level. If we walk through real-world cases, the variety is obvious. Take a small economy engine, say a 1.5-liter naturally aspirated motor converted to a mild turbo running 5 to 7 psi. Expect about 40 to 70 extra horsepower, still street-friendly, often using stock internals and needing only minor supporting upgrades. Step up to a mid-sized gasoline engine between 2.0-liter and 3.0-liter with a moderate turbo running 8 to 12 psi. With an upgraded fuel system and intercooler, these can see 80 to 150 horsepower gains. For high-performance builds, think 3 to 6-liter with large turbos making 15 to 30 plus POCESI, the gains can be explosive. 200 to 500 plus horsepower, but only with forged internals, race fuel or E85, and meticulous custom tuning. Even in the diesel world, a diesel truck upgraded with either twin turbos or a larger single turbo, running 20 to 40 plus PSI, can produce 150 to 400 plus HP increases, often accompanied by massive torque improvements. Factory-installed turbos are built for balance, reliability, emissions compliance, and broad drivability, so you can't just crank up boost without hitting limits. Aftermarket kits, on the other hand, can be built to push peak power far higher, but they demand matching upgrades. Fuel delivery, intercooling, exhaust flow, and often a stronger bottom end. There's no universal turbo adds X horsepower answer. Gains depend on engine size, boost level, fuel, tuning, and environment. For street builds, expect 40 to 150 HP gains. For race builds, 200 to 500 plus HP is possible. The safest and most effective turbo setup treats the entire engine, fuel system, and ECU tuning as one integrated package. Not just a bolt-on.